All right, you're on, Caitlin.
Okay, so for number 1, it's asking about the allele composition of the 4 products of meiosis between these 2 chromosomes. So these chromosomes have been replicated, and so only one of their sister chromatids from each of them is going to be crossing over. So 2 of the gametes are going to just be normal. They didn't undergo crossing over. So one of them is going to be from the normal chromosome. So just all of the dominant, all of the capital from L to X. And the other one is just going to be all lowercase, all recessive from L to X from the inversion chromosome. The other 2 sister chromatids, however, they underwent crossing over between the S and the T. So the normal chromosome and the inversion chromosomes, S and T's don't line up exactly because inversion occurred, and so that swapped the alleles. So one of the products of meiosis is going to have all of these capitals, L, M, N, O, P, Q, R, then lowercase u and lowercase t, because that's the part that crossed over with the inversion chromosome, and then all capital U, V, W, X. The swap of that on the inversion chromosome, the crossover resulted in it being, so these are all lowercase L, M, N, O, P, Q, V, then capital S and capital T. That's what it received from the crossing over with the normal chromosome. Then all lowercase S, R, W, X. And those are the 4 products of meiosis after the crossover occurs.
All right, so now we've got Brene on speakerphone. We'll see how this works.
Okay, so for number 2A, I got meiosis 1 and mitosis, and then for B, I got paracentric inversion. C, I got aneuploidy and familial Down syndrome. For D, I got liver. E, I got Cre-du-Chat and type A hemophilia. For F, I didn't get the answer for that one. For G, I got alternate.
All right, with question 3, Turner syndrome has a total of 45 chromosomes. That's 2n minus 1. Jacob syndrome has an extra chromosome. That makes 47, 2n plus 1. Cre-du-Chat is still 46 chromosomes. That's just 2n. For familial Down syndrome, it's 2n plus 1. So that's also 47. And for type A hemophilia, it is still 2n. So that's 46 chromosomes. For part B in number 3, the terms that go with the Charcot-Marie-Tooth disease, type 1A, is duplication. For Klinefelter syndrome, we have that being aneuploid and trisomy, so having extra X chromosome on a male. For D, we couldn't find any terms that worked for that. So.
All right, so for number 4, the synapse of these chromosomes is going to involve, so there's 2 chromosomes, then they replicate, and they each have their own sister chromatid. The synapse is going to occur between the 2 translocated chromosomes. So DEFP QRST and MNOGHIJKL. Those 2 are the translocated chromosomes. There's going to be the ones that are touching during synapsis. Then there's going to be the normal chromosomes on the outside. So that's part A. Part B, what's going to happen is in alternate segregation, the 2 normal chromosomes are going to segregate with one another and are going to end up in one of the daughter cells. The 2 translocated chromosomes are going to segregate and end up in the other daughter cell. So you have 2 normal chromosomes and the 2 translocated chromosomes. The 2 translocated chromosomes are going to be balanced. So the alleles that one of the chromosomes is missing is going to be found on the other chromosome. And so it doesn't really cause problems. The offspring are still viable. And then at the end of meiosis 2, those sister chromatids are just going to separate. It's going to be the same result. There's going to be 2 of the normal copies of the chromosome in 2 of the gametes, and the other 2 gametes they're each going to have 1 copy of each of the translocated, and they're still balanced. So 2 of the gametes are going to have DEF, GH, IJKL, and MNOP, QRST. The other 2 gametes are going to have DEFP, QRST, MNO, GH, IJKL. And then we all were having trouble with the difference between adjacent 1 and adjacent 2 segregation. So we're going to work on figuring out the difference between those and then the allele composition of the gametes from those.
All right, question 5. Cats have a total of 38 chromosomes, so 2n equals 38. So a triploid cat would be 3n. And in this case, if you do the math, will equal 19. So 3n is 57. The 38 minus 1 is 37. With a deletion on chromosome 7 itself is not deleted, and so we still have the same number of chromosomes. So 2n still equals 38. D, it's the same story. It's just altering a chromosome, not exactly getting rid of one or adding one. So we still have 38, and E is also the same story. So still 38.